Morning, algebra students. Sorry I can't be with you today. We are going to cover lesson 4.4 today, parallel and perpendicular lines. It's kind of a long lesson. I've got a lot of examples to work through, but hopefully you'll see a lot of carryover from what we've been doing over the last few days with working with point slope form and just graphing equations and things like that. So a lot of new information, but hopefully not terribly difficult. Today we are going to look at an equation of the line that passes through a given point parallel to a given line, and we're going to write an equation for perpendicular lines as well. We're going to start off with parallel lines. I think they're probably a bit easier. Two lines in the same plane that do not intersect are called parallel lines. You guys know this already. Lines that are parallel to each other have the same slope. And so if we have this example here of this line on a graph, if I can do this, any line that we place on the graph that is parallel to that line has the same slope. Didn't want to work very well. There we go. And so we can see the original line has a slope here of up 2 over 1, so the slope is 2. And all of these parallel lines that we would drag off there and make copies of, they have the exact same slope, up 2 over 1. This one as well, the slope is up 2 over 1, and it doesn't matter where we place those on the graph. So they would have a different equation, but the slope of the equation of each of these lines would be the exact same slope. And so that comes in handy when we want to write equations for parallel lines then. Write the equation of the line on the graph. So this line, it's the line we just looked at, and so the two things that I need to write a slope-intercept equation, I need the slope and I need the y-intercept. So the y-intercept, starting at the origin, count down 3. So the y-intercept is -3. And then the slope, we just talked about a minute ago, but the slope is up 2 over 1. So slope is 2. So I can write the equation of this line, this red line, as y equals 2x minus 3. And so now I want to write the equation of a line parallel to this one, but it passes through a different point. It doesn't pass through the points that this line passes through. It passes through this point over here, -1, 3, up 3. So it would go through this point right here. So the equation of that line, we just need to use point slope form. Remember, point slope is y minus y1 equals m times x minus x1. We're going to use that form and then solve for y so that we can put it in slope-intercept form. We already know that the slope is 2 because it's got to be parallel to this line, so m is going to be 2. And I've got this ordered pair to fill in for the y1 and the x1. So I would use this form, y minus 3 equals 2 times x. Since this is negative, it would be plus 1. And then just solve for y. Y minus 3 equals 2x plus 2. Add 3 to both sides. Y equals 2x plus 5. So that's the answer to this last part of the problem where it says write the line parallel that passes through this point. That would be this equation. And if we graphed it, starting at the origin, up 5 for the y-intercept, which is right there, and then a slope of +2, we can see it goes through that point right there, even before we draw the line. Like that. Okay, so just a couple more examples similar to that one, just talking about different forms of equations and different ways of getting the slope and things like that. Next one, write an equation in slope-intercept form for the line that passes through -3, 5 and is parallel to the graph of y equals 1/2 x minus 4. So we know that the slope is going to be 1/2 because it's parallel to this line. So using point slope form, y minus 5 equals 1/2 x plus 3. Then just solve for y. So y minus 5 equals 1/2 x plus 3/2, or 1.5. Add 5 to both sides. So y equals 1/2 x plus 6 1/2. And that's all you have to do. That one's done. Next, we need to write an equation in point slope form for the line that passes through 4, -1 and is parallel to the graph y equals 1/4 x plus 7. So this one's actually even easier because we have to do less work once we get it into point slope form. We don't have to do anything else. So we know the slope is 1/4. And all we have to do is write the point slope equation. Y plus 1 equals 1/4 times x minus 4. And that one's done. So the key to working with parallel lines is just identify that slope and then use the things that we already know about writing equations in whatever form they ask for, whether it's point slope form or slope intercept or standard form. Any of those are possible things they'll ask for in your assignment. You just got to identify the slope and write the equation as we've been doing already. Next, let's talk about perpendicular lines. Lines that intersect at right angles are called perpendicular lines. Perpendicular lines have slopes that are opposite reciprocals. We'll see what that means right here. We can see that this red line, if we have a point right here and then the point right here where they intersect, we can count that slope up 2 and right 3. So the slope of the red line is 2/3. And then the slope of the blue line, they intersect right here, and we have a point right here that we can count the slope of. So we would count that slope as down 3, right 2. So the slope of the blue line is -3/2. So we can see that those slopes have a relationship to one another. Slopes of perpendicular lines, just take the reciprocal of the slope of the line you're working with and make it negative or positive, give it the opposite sign. So we can use that information to write equations. Write an equation in slope-intercept form for the line that passes through 4, -2 and is perpendicular to the graph of y equals -2x plus 1. So if I want the perpendicular slope of -2, then I would take the reciprocal, which is 1/2, and make it the opposite sign. Since this one is negative, my perpendicular slope needs to be positive. So the slope of the line that I want to write the equation for would be a positive 1/2. Now all I have to do is put this information into point slope form and solve for y. Y plus 2 equals 1/2 x minus 4. So y plus 2 equals 1/2 x minus 2. Subtract 2 from both sides. So y equals 1/2 x minus 4. And that is the equation for the line perpendicular to this line that passes through the given point. All right, a couple of word problem situations now that we'll work through using this information about parallel and perpendicular lines that we know. So the outline of a company's new logo is shown on a coordinate plane. So this is their logo for the company. And the question first is DFE, angle DFE. Is that angle a right angle? Is it perpendicular? Are the lines perpendicular is the question. And so we need to identify the two lines. First DA and then also BE. If we can show that those two lines are perpendicular, then we can prove that F, angle F here, is a right angle. So all we need to do is find the slope. We've got two ordered pairs for each line. So AD is made up of points 2, 1 and 4, 6. Using slope formula, 6 minus 1 over 4 minus 2. And that would be 5 over 2. Then we need to do the same thing for line BE. I'm going to switch colors so that we can see, so we don't get confused with the numbers here. So line BE has two ordered pairs as well, and we would call those pairs 1, 3. And then, excuse me, 2, 3. 2, 3. And then 7, 1. Okay, so using the same formula now, we would do 1 minus 3 over 7 minus 2. 1 minus 3 is negative 2, and 7 minus 2 is 5. So look at the two slopes that we've just figured out, and answer the question: is it a right angle? I think you can see that it is a right angle because we have a slope of 5 over 2, and then we have a negative reciprocal, negative 2 over 5. And so the slopes prove to us that this is a right angle. So question B then is each pair of opposite sides parallel. So we've got opposite sides here, AC and GE are opposite sides. We also have opposite sides with CG and AE. And so with them graphed as they are, we can pretty well see that they are parallel because we can see where they go. But we also can prove it mathematically. We also have the ability to prove it mathematically by finding the slope of each line and showing that they are parallel. So CG, and we'll just do this with one set of ordered pairs. We'll do CG, and we can find that is 2, 2, 6, and then point G is at 7, 6. So 6 minus 6 over 7 minus 2 equals 0 over 5. So the slope is 0. It's a no slope line, which means it's horizontal. And if we can show that AE is horizontal as well, then we'll show that that they are parallel. And so AE is at point 2, 1, and E is at 7, 1. And so 1 minus 1 over 7 minus 2 is 0 over 5. So it's the same slope, 0. That means they are parallel. Now if we wanted to show that CA and GE are parallel to each other, one thing we could do is show that they're perpendicular. Both of them are perpendicular to this line. And you need to think about what a perpendicular line excuse me, to a slope of 0 would be. And it would be an undefined line. And we can see from these that they are parallel or vertical lines, and vertical lines have that undefined slope. We don't have to have a picture in order to be able to do the types of problems that we just saw. We can use it, do this type of problem just using the information given in the word problem. On the plans for a tree house, a beam represented by QR. And so if you wanted to imagine it, QR might look like this beam, and it intersects beam ST. And we don't have to worry about what the drawing actually looks like, just a picture in our minds what the beams might be doing. And so all we have to do is find the slope of these two lines and see if they are opposite reciprocals. If they are, then they're perpendicular. And so 8 minus 2 over negative 1 plus 6. That would find the slope of QR. So 8 minus 2 is 6. Negative 1 plus 6 is 5. And now let's find the slope, and this was QR. So let's find the slope of ST. And that would be 6 minus 5 over negative 3 plus 8. 6 minus 5 is 1. Negative 3 plus 8 is 5. So we can see pretty quickly that these are not perpendicular lines. They do not have opposite reciprocal slopes. All right, just a couple more examples. Determine whether the graphs of y equals 5, x equals 3, and y equals negative 2x plus 1 are parallel or perpendicular, and explain. Anytime we have equations that look like these, we know right away what the slope is. They're in a form that lets us know automatically what the slope is. Y equals 5. Think about slope-intercept form. Y equals mx plus b. And so I have a y and I have a b value, but I don't have this middle term. And that's because the slope is 0. So 0 times x would be 0. It's gone. So what I have is an equation in the form of y equals b. We talked about those. Those are constant functions a couple of units ago. And so a constant function looks like this, y equals 5, so slope is 0. Anytime I have an equation that looks like this, where x equals a constant, that is in standard form, ax plus by equals c. And so there is no y term in this case, so all we have left is that x value and the c. And so we end up with a line that has an undefined slope. And so x equals 3 is a slope that's undefined. So y equals 5, the slope is 0, and x equals 3, the slope is undefined. So this line is horizontal. Whoops. That's not good writing even for me. Horizontal. And this line is vertical. So a horizontal and a vertical line by definition are perpendicular lines. They have opposite reciprocal slopes. And then we also have this line, y equals negative 2x plus 1. And so negative 2x plus 1 has a slope of negative 2. which is obviously neither parallel nor perpendicular to either of the other two lines. All right, last problem. Write an equation in slope-intercept form for the line that passes through negative 4, 6 and is perpendicular to the graph of 2x plus 3y equals 12. So we want an equation in slope-intercept form that is perpendicular to this graph. So this graph is in standard form, and in order to find the slope of a standard form line, we need to get it into slope-intercept form so that we can find the slope. So all we have to do is get y by itself. We want to solve for y. So subtract 2x. That leaves us with 3y equals negative 2x plus 12. And then divide by 3 on both sides. So y equals negative 2/3 x plus 4. So now I want the slope that is perpendicular to that. Perpendicular slope to negative 2/3 would be positive 3/2. So the slope I need to work with is a positive 3/2. And then use this point in point slope form to write my equation. So it would be y minus 6 equals 3/2 times x plus 4. And then just solve for y. Y minus 6 equals 3/2 x plus 6. Add 6 to both sides, and y equals 3/2 x plus 12. All right, that was our last example. Sorry this was such a long lesson. You had to hear me talk so much. The assignment today is just 10 problems on page 242. We will come back to parallel and perpendicular lines on Monday and talk more about these and probably do some more problems on those then. So this just kind of is an introduction to it. So have a great weekend. Sorry I missed seeing you today.